Hi, I'm Eddie.
I'm Daniela.
My name is Christian.
And we're going to be talking about Werner Heisenberg.
So did you know that Werner Heisenberg is one of the greatest known physicists in the 20th century?
He developed quantum mechanics and the uncertainty principle that led to a major change in what was viewed as the atomic model in physics back then.
I want to know Peace Prize for one of his discoveries in physics.
He was born on December 5, 1901 in Würzburg, Germany. From an early age, his teachers recognized that he is extraordinarily gifted and self-confident in his academics. His father, Dr. August Heisenberg, whom is a professor of Greek language and literature, influences him to pursue a degree in science when he enters university. Heisenberg enters the University of Munich in the fall of 1920. He shows tremendous achievements and he is an eager student that works very hard to achieve his goals. As you can see now, he is saying goodbye to his mother, Anna Heisenberg, as he leaves to embark a journey of a lifetime. As we can see here, Werner is working endlessly at a farm in order to pay for his university tuition, showing his dedication and his balance of work. He receives a doctorate degree at the age of 22. He receives a Rockefeller grant to go to Niels Bohr Institute in Copenhagen, Denmark, where he comes up with his ideas. Then in 1929, he had the opportunity to go on a lecture tour around the United States, Japan, and India. Luckily, he got to show students his brilliant ideas that contributed to major changes in how physics was viewed and, most importantly, science. Then in 1941, he was appointed professor of physics at the University of Berlin and director of the Kaiser Wilhelm Institute for Physics there. His students were greatly appreciative of his work that contributed to major changes in the way they thought and viewed the world. The prevailing quantum theory in the early 1920s modeled the atom as having electrons in a fixed orbit around a nucleus. Electrons could move to a higher or lower energy by absorbing or emitting a photon of the right wavelength. The model worked well for hydrogen, but ran into problems with larger atoms and molecules. Therefore, physicists decided that a new theory was necessary. Heisenberg objected to the current model because he claimed that since one couldn't actually absorb the orbit of electrons around a nucleus, such orbits couldn't really be said to exist. Heisenberg set work trying to come up with a quantum mechanic that relied only on properties that could, at least in theory, be observed. Heisenberg developed a new approach to quantum mechanics. Basically, he took qualities such as position and velocity and found a way to represent them. His assistant, Max Born, identified the strange math in Heisenberg's method as matrices. The new formation accounted for many absorbed properties of atoms. Heisenberg conducted a thought experiment as well. He considered trying to measure the position of an electron with a gamma-ray microscope. The higher energy photon used to illuminate the electron will give a kick, changing its momentum in a certain way. A higher resolution microscope would require higher energy light, giving an even larger kick to the electron. The more precisely one tried to measure the position, the more uncertain the momentum would become, and vice versa. Therefore, he concluded the uncertainty fundamental feature of mechanics, quantum mechanics. And this states the uncertainty principle is that impossible to measure the exact position and exact velocity of the momentum of a subatomic particle or a neutron. But in our day-to-day life, bodies that we come across, it is possible to measure the momentum and the position. But in the cases of small particles, it is not. Mind you, this experiment is not to scale since we did not have the equipment needed.
In conclusion, he contributed to the atomic model because of his discovery in quantum mechanics that led to the quantum theory that recognizes the relationship between particles and atoms.
To the atomic theory was that he calculated the behavior of electrons and subatomic particles that also make up an atom.
He helped clarify the modern view of atoms, their movements, and how many atoms the electron contains.
Focusing mainly on scientific terms, he brought the idea that mathematics should be including and calculating the electrons' behavior and patterns.
Died of cancer February 1st, 1976, when he was 74 years old.